So to look at the review, the first question is that we want to review the following data set and then create a frequency distribution and a histogram that goes along with the ages of 30 consumers who bought a certain product advertised on TV. So if we start with the frequency distribution, I'm looking for how many people are between the ages of 10 and 19. So all I want to do is go through my list and find any number of age of someone who is between 10 and 19. So I'm going to go through, I'm just going to mark each of these, and I can see that there are only 2 people between the ages of 10 and 19. Then for 20, anybody in their 20s, I'm going to identify. Be careful to make sure that you don't miss anyone. We should get 10 people between the ages of 20 and 29. We're going to continue to do this, so this would be a great time to pause the video and count these numbers. Okay, so you should get your frequency distribution to look as follows: 10 to 19, 2, 20 to 29, 10, 30 to 39, 8, 40 to 49, 5, 50 to 59, 3, and 60 to 69, 2. Now, when you're creating your histogram, you want to make sure you give me the title of the histogram. So this is ages of consumers. You also want to make sure that you title your X and your Y axis. So my X axis will be your ages, my Y axis will be the frequency of how often their ages happen. I'm going to go up by 2s for frequency because I notice I have a 10 over here and I don't want to have to add anything to my graph. And for the ages, I'm just going to go up by 10s. Then all these things will get you points, so please make sure that you are labeling appropriately. And then I just want to come over to my frequency distribution and create my histogram from there. 10 to 19 was 2. 20 to 29 was 10. We had 30 to 39, which was 8. 40 to 49, 5. So it's going to be right here in the middle. 50 to 59, 3. And 60 to 69, which would be 2. And this would get me all the points for the histogram. The next question is asking me to find the 5-number summary and IQR for the given data set to create the box and whisker plot. And then we also have a question that says, please find the outliers. So what you want to do to find your 5-number summary, if you have the black calculator, you're going to go to L1, type in these values, second data, 1 variable stats, and then look for all the information. If you're going to Desmos, it's again desmos.com, and you want to hit the stat button. It's under functions, you hit stat, and there's an actual button that says stat. You click that, and then put your data set in using brackets. So pause the video and take time to put this into your calculator or into desmos.com. Now that you put these values into the calculator, you should find that the minimum value is 4, my Q1 is 8, median 12, Q3 of 15, and my max was 17. In order to find the IQR, remember I have to do Q3 minus Q1, so 15 minus 8 is going to give me 7. The next thing I'm going to ask you is find outliers. And remember, there's certain tests that you have to run for the lower fence, and then there's a different test for the upper fence. For my lower fence, it's Q1 minus 1.5 times the IQR, which is going to give me 8 minus 1.5 times 7. And when I type that into my calculator, I get negative 2.5. So I'm going to look through my list, see if there's any number that is negative 2.5 or lower. I can see that there's not. So then I test the upper fence, Q3 plus 1.5 times 7. I'm sorry, 1.5 times the IQR. Which will give me 15 plus 1.5 times 7. When I calculate that, I get 25.5. So when I come into my data set, see if there's any numbers above 25.5. There aren't, so I can easily say that there are no outliers in this data set. Now, remember when we're getting ready to do our box and whisker plot, it is imperative that you have a number line. So I'm going to choose to go up by 2s. You can pick any number that you want as long as you're consistent. Just remember that without this number line, the box and whisker plot gives me no information. Then I'm going to take my values that I found and apply it to the box and whisker. My minimum of 4, my Q1 is 8, median 12, Q3 is 15, maximum 17. And Q3 was 15, and max was 17. And that is how we create our box and whisker plot. You don't have to tell me the specific values. It's given in the 5-number summary above it, and I should be able to read the number line to tell what those values are. For the next one, again, we're finding the 5-number summary. We're going to create a box and whisker plot, and then find if there are any outliers. So I'm going to take this time to take all these values, plug them into the calculator Desmos, and then we're going to find information for a 5-number summary. So minimum, Q1, median, Q3, max. It doesn't say that you have to find the IQR, but we know that we have to have the IQR in order to find an outlier, so we might as well go ahead and label that. And then we also need to find the fences for our outliers. And plug these in. So this is a great time for you to pause the video, put this into your calculator, and record the 5-number summary. So you should get the minimum to be 21, my Q1 to be 30, my median to be 34, Q3 to be 41, the maximum to be 80, and then to find IQR, remember it is Q3 minus Q1, so 41 minus 30 is 11. Then as I plug in my values for my outliers, I'll have 30 minus 1.5 times 11, and that value is 13.5. So I'm looking for any number in my data set that is 13.5 or lower. Then I'm going to come back and find my upper fence. So that would be 41 plus 1.5 times 11. That's where I find the upper fence to be 57.5. So now I'm looking for any numbers in my data set that are above 57.5, and I can see that there are a few of those. So my outliers will be 60, 61, 74, and 80. I'm still having to find plot the box and whisker. So here I'm going to go up by 5 and start at 20. Again, the number line is super important. Without a number line, it tells me absolutely nothing. So if you have this, I'm going to keep going from the number line here. Then I just want to create the box and whisker. So my minimum is 21 right here. You want 30, median 34, Q3 41, then my max goes. The last question I'm being asked is to define the shape of the distribution. I can see that I have a lot of space here, and that is on the right side of my graph, so we would describe this as skew right. That tail is extremely long for that problem. Number 4 is really nice to us. We have given the 18 hole totals for the top golfers in the men's competition and for the women's competition. They want us to compare the spread of the data for the two sets using the mean absolute deviation. They were really nice in not making us find the mean absolute deviation and just giving it to us. So all we have to do is compare. They want to know which group of golfers was more consistent and why. So we know that the women's group was more consistent, and that is because they have a smaller mean absolute deviation. So as we've learned that the smaller the MAD, the closer together my data points are, meaning more consistent the data set is. So even though the men's and the women's golfing groups are pretty consistent, the women are more consistent than the men. Number 5 wants to know, in our own words, what does deviation mean in relation to the spread of our data set? So deviation is simply going to tell us how far apart our data is. We know that the smaller the MAD means the closer together our data is. As we go to number 6, it wants us to describe the shape of these distributions. Well, we know that we have 3 terms. We have skewed to the left, skewed to the right, and symmetrical. Remember, you're just going to trace the outside of your data, so I can find that this first one is symmetrical. So I look at the second one, I face the arrow, so this one will be skewed to the right. And as we do the last one, we face the arrow, so that is skewed left. Number 7, they want us to look at the regression equation for years since 1988 and the vertical drop of a roller coaster. You'll notice it says here we want to find the line of best fit. If I'm looking for the line of best fit, that is really asking me for the linear regression. So how do we know when to use exponential and linear? Well, if it says line, then we know that's linear. If it says exponential regression, that tells me that I need to find the exponential equation. In my calculator, when I type this in, my x values will go in L1, my y values will go in L2. Or if you're using Desmos, the x side of the chart and the y side. So it's a great time for you to pause and put this data into your calculator. Then when you put it in, you should have found that your A value was 14.08, your B value 127.83. Remember, you can round to the hundredth place here. Then when we put it in for the equation, this becomes 14.08x plus 127.83. So that is the equation for the line of best fit. They want us to predict the model of a coaster built in 2018. Be careful, we don't want to just plug in 2018 into my equation, because these are years since 1988. So the first thing I need to do is take 2018 and subtract 1988. And so that's going to give me an x value of 30. So now I can go in and actually plug in 30 into my equation. So y equals 14.08 times 30 plus 127.83. Put that into your calculator, hit enter, and you should find that it is 550.23. You could round that to be just 550. When it comes to making a scatter plot, please make sure you label what each axis is. Down here will be years since 1988. And this side will be the vertical drop. And again, it's completely up to you how you want to scale your graph. I'm going to go up by 50s. You can go up by whatever you want here. 400, 450, 500. And then for years, I'll just go by 2 years. I just want to use my data to create this scatter plot. So at year 1 is 151. It's got to be just close. Year 3 is 155. Year 5, 225. Right there. Year 8, 230. Year 11, 300. That was here. Year 11. Year 12, 306. Close. Year 12, 255. 12, 255. Year 13, 255 again. And then year 15, 400. So that would be the scatter plot that goes along with my data. They're asking you to create a scatter plot. You only have to do what is given in the chart. For number 8, they're asking us to describe whether these are positive, negative, or no correlations. So we know that this is a positive correlation, a negative correlation, and finally we have no correlation. So there's no line of best fit. I'll let it consume all of my data points. Here I can see the middle. Now I consider both of these to be strong, so a strong positive and a strong negative. When it comes to R values, just make sure that you know how to evaluate. Closer it is to 1, the -1, the stronger the data. The closer to 0, the weaker or no correlation that they're on. So they want us to explain how the correlation coefficient relates to the linear fit of a data model. Well, we just said the closer the R value to 1 and -1, the stronger it is. And also for number 8, we need to go back because it asked us to describe the meaning in each situation. So for number 8, part A, the more tickets, game tickets that I buy at the fair, the higher the price will be. For part B, the taller an NBA player is, the lower their three-point shooting percentage is. And then we don't have any correlation, so we wouldn't have to describe that in number 8. Number 10 is another problem where it's just asking us to find the linear regression. Again, because it says linear, I'm using AX plus B. So this would be a great time for you to pause your video and put in your height into L1 and your weight into L2, for your height as your X value and your weight as your Y. Okay, so you should have gotten your equation to be Y equals 0.856x plus 85.91. So that would be my linear regression problem. My A value is 0.856, and that's rounded. And my B value, 85.91, again, that's rounded. So what is the correlation, or does this correlation coefficient suggest a good linear fit? Well, I found the correlation of the coefficient to be 0.49. And we do say that's positive and weak, but no, this would not be a good fit. So they want us to predict the normal weight for a man who's 84 inches tall. And again, inches is my x value, so I'm just going to plug it into the equation. So y equals 0.856 times 84 and plus 85.91. And I find that the predicted weight is 157.81. Now, the last question is dealing with two-way frequency tables and frequency distributions. So I just have to read carefully in this problem to make sure I'm filling in my boxes the right way. So our managers, staff, and assistants were given three options for holidays activities: a potluck, a dinner at a restaurant, a gift exchange. So 5 out of the 11 managers wanted dinner. So I know total number of managers now is 11, and that 5 of them want to go to a dinner at a restaurant. 3 want the potluck. Now I'm still able to find how many want the gift exchange here, because 5 plus 3 is 8, and 11 minus 8 is 3. Next sentence, 11 of 45 staff members want a gift exchange. Well, I know there's 45 total staff members, and then 11 of them want to do a gift exchange. 18 want to do a dinner. So at this point, I can add 18 plus 11 to get 29. And say 45 minus 29 to get 16 staff members that would like to have a potluck. Finally, 10 of the 32 assistants, so 32 assistants, 10 of them want a dinner, while 8 want a gift exchange. So 10 plus 8 is 18, 32 minus 18 gives me 14. And now I can fill in the rest of my chart by simply adding. 3 plus 16 plus 14 is 33, so 33 total people wanted a potluck. 5 plus 10 plus 18 is 33, so 33 people wanted a dinner in a restaurant. And 3 plus 11 plus 8 is 22, so 22 people wanted a gift exchange. Now when I add up how many total people wanted potluck, restaurant, and gift exchange, I should get 88. And that should be the exact same thing as when I add up how many managers, staff, and assistants there are. If these numbers do not add to be the same thing, we've done something wrong. Our second table wants us to create a relative frequency. Remember, relative simply means a percent. So we're finding a percent based on the row for each data point. So I'm going to take, in order to solve these, 3 and divide by 11, because that is the total for my row. So here it'll be 3 divided by 11, and you would need to multiply that by 100. 5 divided by 11, 3 divided by 11, 11 divided by 11. We have 16 divided by 45, 18 divided by 45, 11 divided by 45, finally 45 divided by 45. 14 divided by 32 here, 10 divided by 32, 8 divided by 32, and then 32 divided by 32. And for the last row, should be 33 divided by 88, 33 divided by 88, and 22 divided by 88. Also 88 divided by 88. Again, what you're doing is you're dividing these, then multiplying by 100, and you can round to the 10th place. So take time to hit pause and put all these into your calculator. Okay, now that you've done the relative frequency by row, it is now asking us to do relative frequency by the column. So I'm just going to look. There were 3 managers out of a total of 33. And then I'm just going to go down the row. So we have 16 divided by 33, 14 divided by 33, and finally 33 divided by 33. Again, you're going to divide these and then multiply by 100. For a restaurant, 5 out of 33, 18 out of 33, 10 out of 33, and 33 out of 33. For gift exchanges, 3 out of 22, 11 out of 22, 8 out of 22, and 22 out of 22. And for the last column, the 11 out of 88, 45 out of 88, 32 out of 88, finally 88 out of 88. And then again, this would be a great time for you to pause, find these percentages, and write them down. So the last question is, if you were in charge of the holiday activity, based on the data above, which activity would you choose? You support your choice with specific values from your table. Well, if it were me, I would choose between a potluck and a restaurant, and then I would just decide from there based on numbers. Again, as long as you can support your evidence with values from the table, so you need to make sure you quote and put some values from your table in your answer, you will be correct.